Hello everyone. Today let us discuss practice assignment solutions of week 4. Let us start with multiple choice questions. What will be the equation of the tangent to the curve f of x is equals to 2x square plus 9x plus 20 at a given point minus 3 comma 11. Let us try to plot function f of x and minus 3 comma 11 roughly. Suppose the figure 4.1 is a rough diagram. This is our f of x, which will be equal to 2x square plus 9x plus 20. As the coefficient of x square is 2, which is positive, so our f of x will be an upward parabola like this, and this point will be 0 comma 20 y-intercept. So also minus 3 comma 11 is this, and we are supposed to find this tangent that touches this minus 3 comma 11 and passes like this. Let the equation of the tangent be y is equals to mx plus c, where m is the slope of the tangent, which is also equal to the slope of f at point minus 3 comma 11. Now, any quadratic equation of this g of x is equals to ax square plus bx plus c form, where a not equal to 0, at any given point x, the slope will be 2ax plus b. This we already know. So in our case, we have a is equals to 2 and b is equals to 9. Also we are trying to find the slope at point minus 3 comma 11. So my x will be minus 3. Now if I calculate the slope of f at minus 3 comma 11, I will get 2 times a is 2 and x is minus 3 plus 9. So 2 times minus 3 gives me minus 12 plus 9, which gives me minus 3. So the slope of the function f at point minus 3 comma 11 is minus 3, which is same as the slope of this tangent. So we can conclude that slope of the tangent line m is equal to minus 3. So now we are supposed to find the y-intercept, which will be this. Since the tangent passes through the point minus 3 comma 11, it should satisfy the tangent line. So if I substitute minus 3 comma 11 in y is equals to mx plus c, and I already got the value of m, so y will be 11, m will be minus 3, which we have got already, and our point x coordinate of our point is minus 3. If we substitute that, we will get c is equals to 2. Therefore the equation of the tangent we are looking for will be y is equals to m is minus 3, so minus 3x plus c is 2, so it will be plus 2. So final equation will be y is equals to minus 3x plus 2 will be my tangent line. So answer to my first question will be option B. Let's move to the second question. Find the length of the line segment on the straight line y is equals to 2 bounded by the curve y is equals to 4x square. So we were given curve y is equals to 4x square and the straight line y is equals to 2. Let's try to draw this curve and line on xy plane. It will roughly look like this. This is x-axis, this is y-axis, and the curve y is equals to 4x square will be roughly passes through the origin, and it is symmetric about y-axis because the value of b is 0 and c is 0. We have only y is equals to 4x square. Also observe that this is the line y equal to 2. Now we are supposed to find the length of this line segment. So in order to find that, it is enough to find the intersection points and calculate the distance between those 2 points. So in order to find the intersection point, let's substitute y is equals to 2 in this equation. We get 2 is equals to 4x square, and x square will be equal to 1 by 2, and x will be equal to plus or minus 1 by root 2. And if I substitute x is equals to plus or minus 1 by root 2 in this equation, we will get y is equals to 2. So basically, the intersection point will be minus 1 by root 2 comma 2 and 1 by root 2 comma 2. So we are very much near to the solution. So it is just enough to find the distance between this point and this point. So using distance formula, we can calculate it. So the distance formula is root over y2 minus y1 whole square plus x2 minus x1 whole square, where x1 comma y1 and x2 comma y2 are the points. So in order to put the distance between these 2 points will be equal to this. In our case, y2 is 2, y1 is also 2, and x2 is 1 by root 2, and x1 is 1 minus 1 by root 2. So if we calculate this, we will get 0 plus root 2 whole square. Finally we get root 2. So option B is correct. Third MCQ is, Mr. Mehta has 2 sons. Both sons send money to their father each month separately, as m1 of x is equals to x minus 2 square whole square and m2 of x is equals to x plus 2 whole square. See, this is the amount sent by the first son with respect to the month, and m2 of x is the amount sent by the second son to Mr. Mehta. If x denotes the month, then choose the curve which best represents the total amount p of x received by Mr. Mehta every month. So we were given that first son sends x minus 2 whole square amount which corresponds to each month, and m2 of x is the amount sent by the second son on xth month. So the total amount received by Mr. Mehta will be sum of these two. So p of x will be equal to m1x plus m2x. m1x is x minus 2 whole square and m2 of x is x plus 2 whole square, which we simplify, we get p of x as 2x square plus 8. So this is a quadratic equation. Now let's check the options one by one. We have got p of x is equal to 2x square plus 8. So in my quadratic equation, if I compare it with general quadratic equation of the form like f of x is equal to ax square plus bx plus c, here the value of b is 0, a is 2 and c is 8. So if b is 0, we can say that the curve needs to be symmetric about y-axis. So in that case, our first option will be ruled out because this is not symmetric about y-axis. Also, if we observe, in the 0th month, that is p of 0, I get 8. But in option 2, it passes through origin. It shouldn't pass through origin. It should cut y-axis at 0, 8 here somewhere. So option 2 is also ruled out. Coming to option 3 and option 4. If we observe, we have function as p of x is equal to 2x square plus 8. If I calculate the 4th month, like Mr. Mehta receives p of 4 amount on 4th month, that will give me 2 times of 4 square plus 8, which will be nearly 40, which will be equal to 40. So if I compare option 3 and option 4, in my fourth one, it's almost touching 60. But in option 4, it gives me 40 exactly. Also it passes through, it cuts y-axis on 0, 8. This can also be ruled out. Option C is also ruled out. So considering 4 options, option 4 will be somewhat best representation for the P of X. Let's move to the next question. A civil engineer found that the durability D of a road she is laying depends on two functions y1 and y2 as follows. D is equal to A times y1 times y2, where A is greater than 0. Functions y1 and y2 depend on the amount of plastic X mixed in bitumen, and their variations are shown in the graph given below. So this is the graph we were given, and y1 and y2 are these two lines, where y1 passes through 0, 6 and 6, 0, and y2 passes through 0, 1 and 7, 8. So now find the values of the functions y1 and y2. We have to find the values of y1 and y2 such that the durability of the road is maximum. So let us find the equations y1 and y2 with respect to x. So we have 2 points where y1 passes through. If you use 2-point form, we can calculate the equation of y1, which is 0 minus 6 divided by 6 minus 0 equal to y1 minus 0 by x minus 6. So this will be minus 1. This will be equal to y1 by x minus 6. If we cross multiply, we will get x1, y1 is equal to x plus 6 minus x plus 6, and that gives us y1 is equal to 6 minus x. And similarly, if you use the 2-point form where y2 passes through 0, 1 and 7, 8, we will be getting y2 is equal to x plus 1. Okay, now we got the equations y1 and y2 with respect to x. Let's substitute this in. D is equal to A times y1 and y2. If we substitute y1 and y2 in terms of x here, we will get D is equal to minus ax square plus 5ax plus 6a. Here we were given that a is greater than 0, which implies that minus a is less than 0. That means coefficient of this is negative. X square is negative, which tells us that the quadratic equation is a downward parabola, and the durability of D and the maximum occurs at x is equal to minus b by 2a. So here we have b value 5a and a value minus a. If we substitute that, we will get durability of D of the road is maximum at x is equal to 5 by 2. So we got the value of x. Now we substitute this value in y1 and y2. We will get y1 is equal to 6 minus x and our x. In order to get the maximum, our x should be 5 by 2. So if we substitute that, we will get y1 is equal to 7 by 2. And y2 we have x plus 1. If we substitute 5 by 2 there also, we will get 7 by 2. So our values of y1 and y2 are 7 by 2, 7 by 2 in order to get the maximum durability of the road. Let's see the fifth question. Let A be the set of all points on the curve defined by the function f1 of x is equal to x square minus x minus 42. And let B be the set of all points on the curve f2, which is the reflection of the curve f1 with respect to x-axis. So for any reflection, we need to mention on with respect to some x-axis or y-axis or any line. So if C is the set of all points on the axis, then choose the correct option regarding the cardinality of the set D, where D is given like. So let's plot f1 of x and f2 of x roughly. So let's assume that this is a rough diagram we get. As f1 of x is x square minus x minus 42, the coefficient of x square is positive, we will get an upward parabola. Its reflection with respect to x-axis will be downward parabola like this. And f2 of x is nothing but minus f1 of x. So that will be equal to 42 plus x minus x square. So now we have the set A is nothing but all the points on f1, and set B is all the points on f2, and set C is all the points on both the axes. Now we define a new set D as follows: A intersection B union A intersection C union B intersection C. We are not concerned about this set, but we are concerned about the cardinality of this set, that is the number of distinct elements in the set. So let's find the number of elements in A intersection B and A intersection C and B intersection C, and let's union them. So in order to find the number of elements in A intersection B, this is the points on A and this is points of B. So the points which contain on both the curves are nothing but intersection points P3 and P4. Observe that they are the roots of this equation, the roots of this quadratic equation. So they will be, P4 will be my point 6, 0 and P3 will be my point minus 7, 0. So I will be having two elements from A intersection B, which are P3 and P4. Now A is the set of all points on F1 and C is set of all points on axis. See, if we observe, F1x cuts x-axis at 2 points and y-axis at 1 point. So there will be 3 elements. If you see the graph, 3 elements are P3, P2 and P4. Like now we got A intersection C is P2, P3 and P4. And lastly we are concerned about B intersection C. So B is the set of all points on this curve F2 and C is same as the all points on x-axis and y-axis. So here also we have 3 intersection points. So basically they are P1, P3, P4. If you union all this, we will get P1, P2, P3, P4. We won't consider duplicate elements here because it doesn't matter when we concerned about the cardinality of any set. So I got D. Now D has 4 elements in it, so the cardinality of D will be 4. So the answer is option C. Let's see the last MCQ of this assignment. Let f1 of x be x square minus 25. Let A be the set of all points inside the region by the curves representing f1 of x and its reflection f2 of x with respect to x-axis, excluding the points on the curve. Choose the correct option. So let us try to plot f1 of x and f2 of x and find the inside region. So this will be a rough diagram of the point of the curves f of x and f2 of x, and this is x and this is y axis. So now we are concerned about this region, and my set A will be all points inside this region, and intuitively we can say that there will be infinitely many number of points inside this, and we also observe that the points will be in between these two lines. Like this line is x is equals to minus 5, and this will be x is equals to 5, and in between these two lines, and this line is y is equals to 25, and this line is y is equals to minus 25. So it will be inside this rectangle box. Now let's check the options. Our first option is the cardinality of A is 2. It is wrong, because cardinality of A is infinite. There are infinitely many number of elements in the set A, so we cannot say the cardinality of A is 2. It is false. The same goes with option 2 also. The cardinality of A is not 4. Now, the y coordinates of the points in set A belong to the interval minus 25 comma 25. It will be true, because see, every point inside this region will lie in between y is equals to minus 25 and y is equals to 25 line. So whichever point we choose, the y coordinate will be in between these two. Also, we were given that excluding the points on the curve, so there won't be minus 25 and 25 also. So that will be an open interval. That is why option 3 is correct. If option 3 is correct, option 4 is false, because it has given that it is closed interval. It is including minus 25 and 25. We should exclude that points on the curve. So that is why option 4 is false. X coordinates of the point in set A belong to the interval closed interval minus 5 comma 5. No, this is also false, because whatever the point inside this region will have x coordinates between minus 5 and 5, but it won't include 5 and minus 5 and 5. It should be open interval minus 5 comma 5, then it will be true. 5 is also false. X coordinates of the points in set A will be all real numbers, because f1 is a quadratic function. This is false, because just now we have seen that the x coordinates of the points inside this region will lie in between minus open interval minus 5 comma 5. It will not be the all real numbers. So option 6 is also false. So answer to our question 6 is option 3.